Greetings everyone, this is Yogeshwari bis 21 MF3 I am 20 and Riya Arjun Singh Mehta 21 MF3 I am 14, and this is our submission for the Mechanical Sessional Group project, which is a part of the 2 credit course Mechanical Session ME29002 under the Department of Mechanical Engineering IIT Kharagpur. So for the problem statement that we are working on it is the wind cell wiper mechanics. Now the graphical part of the solution will be explained by my team member, and I will be explaining the numerical and simulation part. So handing over. A 4-bar linkage, also known as 4-bar mechanics, is a type of kinematic linkage that consists of 4 rigid bars connected by joint or power. It's like a closed loop and exhibit a range of motions and mechanical advantage. 4-bar linkages are widely used in various applications such as machinery, robotics, and automobile to achieve control and predictable movement, including rotation, translation, and oscillation. The 4-bar linkage consists of 4 links, each of which make a pair at A, B, C, and D. The 4 links may have varying length. The mechanics are also known as planar 4-bar chain mechanics. There are 4 terminology to be considered while learning the 4-bar mechanics. Rocker: any link that does not revolve is referred as rocker. Crank: a link with the ability to completely rotate is crank. Connecting rod: the frame's opposing link is referred to be as connecting rod or a coupler. And the working principle of the 4-bar linkage or chain mechanics is the motion of rocker causes the connecting rod to transmit motion to the crank to move through specific path, which is determined by the length of the links and position of the joint. Disciplined placement analysis of 4-bar mechanics involves determining the position of the link at any given time. This can be done using the Grashof theorem, which describes the condition for a 4-bar linkage to have a unique and complete motion. The theorem states that in the 4-bar mechanics, the sum of the shortest and the longest link length should be less than or equal to the sum of the other 2 links for this linkage to have complete rotation. In this context of 4-bar mechanics, displacement analysis would involve determination of position of the 4 links at any given time based on the initial position and the motion of the rocker. This can be complex due to interdependence between the links, but it is crucial part of understanding the operation of the mechanics. We can see the question is given that we have to synthesize and make a simulator for the windscreen wiper mechanics. So we know that the motion of the windscreen wiper mechanics, how it moves. So to explain that, we saw the diagram that here we are considering the overall linkage mechanics, which consists of 0.42 A, B and O4, and how the next diagram will show the evolution of how it is solved. So we see that it moves and it has some imposition to locate the extreme position. We know that it has 2 dead centers, but the first dead center will be formed when the points A, 2 and P will be in straight line. So that this will be the extreme position for the wiper, which where the point C is located. Another dead center configuration will be the 0.02 A dash and B dash will be in the straight line, and the wiper will be in C dash position. So to draw this configuration, we take the point and draw the arcs O to B. Also take the point O2 and draw to B dash, and the O4 from the O point 4 point we draw O4 BR, and for B dash R can we join the lengths to pump the dead center configuration, and the delta angle is also given. According to that, we drop the lengths which we require even or cushion. So the area will be there stated portion which is given to the area wiper the mechanism, where the extreme position of the wiper are C and C dash.
So now we will take a look at the numerical analysis of the problem and MATLAB simulation. So let's begin. The given problem has a fixed geometry and is subject to certain geometrical conditions. These geometrical conditions are given in the question itself and are existing on the basis of geometry and orientation of the wiper and due to the fact that it has rigid bodies that cannot change length. So let me take you back to the question now. Here in the question we can see that certain things are constant, like the vertical distance of output from O4 is fixed at 50 millimeters and the horizontal distance of O2 from O4 is fixed at 150 millimeters. The angle delta is fixed at 10 degrees and link AB has a fixed length of 200 millimeters. Likewise, EO6, O4B and O4C and every other link has a fixed length which cannot change. Now these are the geometric conditions which are imposed. Now with those in mind, we vary the coordinates per position of the crank. As the position of the crank varies, all the other factors that depend on it, they also vary, and this brings about the displacement analysis. So the displacement can be found by finding the location of the coupler for every position of the crank using these geometrical conditions. So what we do in MATLAB is that basically we provide the condition of the links, like the length of the links and the geometrical constraints which basically position the link with respect to its environment, and then based on that we rotate the crank. And how do we move the crank? We set it to rotate about a fixed point and then plot the coordinates of the crank as well as the other links that depend on the position of the crank, since the entire thing behaves as a single mechanism. This is enough to bring about the movement of the wiper and the final link that causes the final wiping action. Likewise, the velocity analysis can be done by a Jacobian analysis. However, this is not really the focus of what I have done. Now, let us take a look at the simulation. Before that, let us have a brief look at the code. So, in the code, initially we are specifying the length of the links as well as the position of the links, where they are located, and the various constraints. The constraints are given from the various angles, like the angle between the various links, the length of the links, like there was particular case of delta that was 10 degrees, and other conditions those are implemented. And after the entire setup is made, after we set up the entire mechanism, we first build up the parts and then we make it move. So after the mechanism is set, we try to rotate the crank, and as the crank rotates, as its coordinates changes, its effects are seen on the coordinates of the other links of the mechanism, and thus the entire windshield wiper mechanism moves. But what is our focus here is the motion of the ultimate wiper which carries out the wiping action. So now let's run the simulation and have a look at the results. This is the simulation. The angle between the extreme configurations is 26 degrees based on the parameters that we input to the question. And the simulations, suppose the motion of the windscreen wiper as it moves from the from one dead center configuration to the other dead center configuration, bringing about the two extreme position of the wiper. The red zone marks the area wiped by the wiper mechanism. The area can be changed by changing the various lengths and the geometrical constraints. However, the geometrical constraints are fixed in the problem, so let's leave it at that. This is the animation, the red zone showing the area of the wiper.